So hi again, everyone, and welcome to this session on how data can enable new robotics applications in manufacturing. My name is Paul, and I work for Funding Box, a company that manages various European projects and funding opportunities, for which many are related to the fostering of the use of robotics. So I'll be giving a brief introduction to the topic, before then giving the floor to our speakers. That will be Nina, Francisco, and Marcos. So as a short introduction, I'll just go to the next slide. Seems to block, just a sec. There we go. So the speakers and myself, we are all part of two European sister initiatives that actually aim to empower manufacturing SMEs with agile production tools and processes that involve robotics. So what do we mean by agile production? So agile production actually refers to the capacity of these SMEs to react fast and with quality to changing customer needs, and in general to very changing market dynamics. So this topic is even more relevant in a pandemic context, where basically from one day to another, our consumer habits totally changed. And obviously this impacts the way a company should produce its products. So what we mean then by empowering these SMEs to robotics is the following. It means basically providing factories with robotics-related solutions that can help them improve their productivity, but also envision new business models thanks to the possibilities that are brought by robotics. So there are many areas in a factory that can benefit from robotics-related solutions. So we can maybe just see a couple so that you have a concrete idea of it. So this, for instance, is an example from DIH², one of the initiatives in which we are involved. We here funded and helped putting in place a system relying on cobots that, one, helps to automate some manual processes, and two, also to widen the product portfolio of the manufacturer, since it could basically do some things that humans could not do before. Another example is the following. So that also comes in the framework of DIH². We fostered, through funding and technical assistance, an experiment involving robots that fully automate ham packaging process and that detect quality flaws. So these are very concrete examples of what we do through these two initiatives I mentioned. So DIH² on the one hand and TRINITY on the other hand, two robotics initiatives. So what we generally do is that we invite manufacturers that can have challenges that can be solved through robotics. And on the other hand, we invite tech providers that can solve these challenges, and we invite them to work together to develop a solution, and we give assistance in the development of this solution. Now, one, I think, very relevant question considering the main topic of this event is how does this, the topic of the session relate to data? So here's the thing, we don't only implement robotics, we implement a whole system behind these robots. So the system allows us to collect data related to performance, to monitor this data, and to make predictions. So it's not just about the robots, it's about the robots and the data we can collect thanks to a digitalized process. And it allows to improve process over time, making it faster, ensure product quality, etc. So in short, we produce technology, but then this technology produces data, and this data in turn can be used to make production processes and supply chain more agile. So this is how data, robotics relate. It basically allows us to continually improve the processes of the factories. So there are many things at stake in order to achieve this: data collection, data analysis, and so on. So today, in order to talk about all of these stakes, we've got three speakers. We've got Francisco, who's a technical expert from the FIWARE Foundation, and he's from the DIH² initiative. Also from the DIH² initiative, we've got Marcos, who's project manager at the International Data Spaces Association. And we also have Mina, who's a professor at the Tampere University in Finland. And she is from the project TRINITY. And myself, not actually a speaker, I'm a moderator here for the session, and I'm more particularly involved in the DIH² project. So on the menu, basically three main topics that will be tackled. The first one being data flows in robotics application design. That topic will be dealt by Mina. Then in a second part, we'll have digital twins for robotics-based agile production. So this is something that Francisco will be talking about. And then finally, trustworthy data ecosystems and their impact on agile production. This is something that Marcos will tell you about. So this is it on my side for an intro. So I guess Mina, you can take the floor from now.
All right, thank you. I will share my screen. One moment.
I'll just add meanwhile that you are all very welcome to ask your question during the whole session. We have a dedicated time after each part for Q&A, so you can send your questions in the chat and I'll ask them out loud to the speakers. So feel free. Thanks.
All right, so hello all, my name is Minna Lantz. I'm the coordinator of Trinity project, and I have a privilege to a little bit discuss about the data flows. My background is in the production engineering, so the view for the robotics data collection is always on calculating the value added and non-value added time, and every action what we take should reduce the non-value added time in production. All right, but I will give you a brief outline of the Trinity project and then a little bit on the topics what I was planning to discuss today. So I'm trying not to take too much time and stick on the 15 minutes. It's usually quite hard for the professors to stop talking. But let's start. So the Trinity project, this is the project for DIH² dealing with the challenges on the agile production. Our ambition is to help the European SMEs to become more agile in their production. So in Trinity, we have three thematic areas. It's the robotics, of course, we are dealing with the robot systems, but robots are not the standalone systems. So they are connected, collecting and creating data. And in order to be connected to the systems and to actually the factory floor, there has to be the ICT, IoT involved. And of course, in future, the systems are more and more networked, so the cybersecurity will become much more important than it has been now. While we have the same approaches on building the sustainable ecosystem for supporting the SMEs within the Trinity and DIH², we have some differences. The Trinity's approach to make ourselves interesting for the European SMEs is to focus on developing the technical modules and build use cases out of the clearly defined technical modules. So after this 2 years of runtime, we have almost 40 different use cases, and we expect to have roughly 50 different technical modules what we have used to build these use cases. And these use cases are dealing with the robotics, different types of robotics. We are always talking about the physical systems, and then the software part on how to make these physical systems more intelligent. So our perspective, the robotics, they always come with the intelligence and the physical appearance. And then the cybersecurity is good question. So that remains challenging in future. But this is the approach in Trinity. I structured my presentation with the going from the larger digital transformation expectations, what are the visions, then the data flows, what are also envisioned, and a little bit on the origins of the data, so where the data actually comes from, or if it doesn't come. And finally, some questions on bridging the gap on the systems what we are using today. So I took this slide, actually this is from the digital manufacturing lectures I gave from the students, but it shows the different life cycle phases where the product actually generates the data. And we should remember that all of these are actually data inputs, and they are more or less reliable inputs. But nevertheless, we should note them that all of the life cycle phases, as the product might have modules, so it might be assembled of the modules, and the modules itself or the parts could have several life cycles. And all of them are generating the data. And at the moment, the data flow is not exactly a flow, it's more like the sprinkler system delivering bits and pieces of data. And now the future challenges is that how we are actually creating it as a data flow. Some use the word digital thread as a background. Of course, there are a lot of other words for describing the data flow. But the data flow itself, that we actually generate the flow in future, is one of the biggest challenges. At the same time, we have quite high visions and expectations coming from the European Commission and from the member states. So the digital transformation is taking the new steps, and we expect to see data spaces coming and the marketplaces coming, and then we are dealing with data. There is a quite good business prospects for utilizing the data what the manufacturing sector is generating. I'm only focusing on the manufacturing because that's my core area. But nevertheless, the manufacturing sector is creating data more and more. And now the question is that how we are going to use that data in a higher level. There is a challenge is because the most of the systems what we use for designing and commissioning and operating the robotics and automation systems in the production, they are not designed to generate data for this purpose yet. So there is a challenge that how we are going to change our design methods, tools to support the utilization of data in the later phases of the product life cycles. The practical view is that when we are developing the production in general, the robotics, for example, we are creating the new cell. Here are few of the data inputs, only few, just remember only few data inputs what we have to create. We usually use the CAD systems, CAM, and different simulation systems to realize these robotics cells. And at that time, we define and describe the product requirements and the system capabilities up to some level. On the other perspective, if we look for the factory operations and dealing with the production flow, so then we have the simulations, advanced production planning, scheduling, and control systems for creating the data flow for this current state production. That's the simulated data and envisioned data, or calculated data, I would say. And then the third data source is actually the collected data from the operations itself. And these are, as you well know, that they are connected, but they might not be the same. But these are the inputs what we used to have to deal with when we are designing the robot systems. So the design data, simulation data, and then the collection data. We have several solutions, I would say that local solutions. So they are answering the one challenge in the design flow or the commission or operation flow. So on the one hand, we have specific commercial tools with the dedicated purpose and focus. And I took some of the examples which are used in smaller companies. They cannot necessarily purchase the full software suites, but most of the SMEs dealing with the manufacturing challenges, they have multiple different small vendor tools which are dedicated for single use. So there might be a simulation tool, then might be a control production planning tool or the robot fleet management tools. At the same time, as we have noticed in the Trinity, we have fully open sourced and community originated tools. So we are creating new tools and design systems. When I look for the Trinity use cases and the modules, we strongly rely on the robotic operation system, ROS. And it's completely heterogeneous system. It doesn't have any hierarchy. We are creating solutions for the smaller scale. And it's very flexible, but comes without support or good descriptions. But the companies have started to accept the ROS as one of the commissioning or operation tools, and it will gain a little bit footing in the future. And now the question comes that how we can merge these two different worlds, where the one is hierarchical, dedicated, and the other one is without hierarchy, complete freedom for designing the system. Both are generating the data or utilizing the data. The other expectation is that we move towards the highly reconfigurable, hyper-connected and scalable factories based on the fluctuating demand. So I took the APP Future Factory video. I particularly like the visualization of it, but it shows how the production should reconfigure on at least in a physical level, but also in a software and safety level. But that's something for the future. At the same time, we have a lot of emerging novel technologies which will be used in this setting. If we had highly modularized, well-described interfaces for the hardware and software and the safety system, then the reconfiguration could be easier. But like I said, we have a lot of novel emerging technologies coming which are not standardized. They don't necessarily have clear interfaces, or they are changeable. or the lifetime is shorter as the development goes on. But these both are combined into the future factories because we want to support the emerging of novel technologies. That's the only way the agility can be increased in future. So we come to the question that on the cell level, we have dedicated tools, and expectation is that we will have commissioning of flexible, reconfigurable, and heterogeneous autonomous systems and robots more and more in future. That's the one design sort of a cluster. Then we have the factory and local level, so we need to orchestrate the system that it actually produces the physical products, because that's the main idea for the factories. And in order to be sustainable, the production efficiency has to increase. This means that every emerging technology what we develop should improve the production by reducing the non-value added time and increasing the quality. And in the network level, we could share the capabilities of these systems, and the capacity of the machinery in a global supply network could be done via the marketplaces what are envisioned in the higher level. But now comes the question that we have so heterogeneous data, so sprinkler type of system that delivers different data inputs. So how we are going to create this big picture that could be beneficial for the future manufacturing sector. So this means that we need to have solutions that are scalable and describe enough in a form of a minimum viable product interfaces that we can connect the systems. So this was my short presentation on the data flows and expectations in the future. And if you have any questions or comments, please do feel free to ask. Otherwise, I will give floor to the next speakers who will provide solutions on how to bridge the gaps in the future. So thank you.
Thank you, Mina. So far, no particular questions. So I think we can actually move on. Let me check if we have some. No. Okay. Well, in this case, we can move on, as you said, directly to the solutions, and that would be Francisco then.
Okay. Let me share my screen. Please, Paul, confirm that you can see the screen.
Yep, I confirm.
Yep.
I can see it.
Great. Okay, thank you. Hello, everybody. My name is Francisco Melendez. I am the technical expert in the FIWARE Foundation that takes care of the robotics roadmap. I am also working in the DIH² project, and then I have strong connections with the smart industry and production systems. And what I am going to talk today about is an extension of what Mina has presented, in which I will cover how we internally in FIWARE are giving a vision to generate these digital twins and take the most out of these data twins of cyber physical systems, and the particular use case we have in DIH², in which we are materializing this concept of an open platform for agile production. So these are the two main topics I will cover. The introduction will focus on this digital twin thing, and then the second part will elaborate on the use case of the agile production, then the platform, and then the use cases we are now conducting as field experiments in real factories across Europe. So let's start with this vision on the digital twin. In FIWARE, we see this vague or holistic concept that is becoming more and more trendy around digital twin as the glue to communicate real-world cyber-physical systems and all the processes, operations, and data exchange that are required. There is no one digital twin model that fits in every use case, but the combination of multiple atomic, very small digital twins is what allows really to implement this interface between the use case, the requirements, and the composition of multiple scenarios. So to us, in Powered by FIWARE Digital Twin, every system that is able to publish or consume data becomes a context data source and interacts through the digital twin representation with other systems or to serve data to human stakeholders that want to access it via some graphical user interfaces or whatever device that is able to give visualization to the data. Then not only our approach is focused on serving the data to humans, but on enabling the interoperability between systems. And this is what I am going to elaborate on in the next slides. In fact, this vision is not only limited to the level of designing and building and deploying a vertical solution. When I talk about vertical solution, I mean a solution for smart warehousing, a solution for the palletization of items, a solution for complex welding operations. This is something in which the digital twin representation and its data has a lot to do, but the digital twin representation goes beyond that. And for instance, it is the interface to the integration of multiple systems, this automation pyramid that was presented by Mina, how manufacturing execution systems, enterprise resource planning systems, workstation with industrial IoT-enabled assets, how they connect. Well, this is all in our vision. This is all enabled by the abstraction materialized in the digital twin representation. In particular, in my talk, I am going to cover these two first scenarios, and my colleague Marco from IDSA, which is who is the next speaker, will cover the third part. Okay, but what is exactly what we are referring to as a digital twin? Well, to us, a digital twin is a digital representation of an asset. An asset can be something physical or logical or a piece of data that represents something of value for the company or for a given scenario. So our way to represent it is through attributes. These attributes can be descriptive properties or relationships, links to other entities. These attributes might be dynamic or might be static information that is relevant to understand the context of the digital twin. And our experience tells us that typically one key attribute for every digital twin is associated with a location, which might be a particular server or a physical location, which names where, for instance, a particular workstation is deployed in a factory. So we understand context data as these collections of digital twins. And regarding trying to give answers to some of the questions that were raised during the presentation of Pina, as we are facing the problem, our cornerstone elements for these interoperable and replicable solutions are the standardization of the APIs for getting access to this data and the harmonization and definition of common shared data models that allow us to create this collection of digital twins. In particular, FIWARE is one of the organizations that is driving this standardization and adoption. NGSI, in particular NGSI LD, which is the last version of NGSI, is the API, the standard API, standardized by ETSI, together with FIWARE, other partners like, for instance, NEC, are standardizing this API. And this Smart Data Models initiative is building a collection, a huge repository of common information data models, open. Everything is open, and everyone can just contribute through GitHub with their proposals for standard data models. We are not only focused on smart industry, we are doing the same, following the same approach in multiple domains like smart energy, smart cities, smart healthcare, or agriculture. But today I will focus more on my field of expertise, which is the smart industry. Well, this slide aims to capture what we are doing, the change in the approach we are following. Here on the left side, precisely, you can see this automation pyramid that was presented by Mina, in which often all the systems are attached to a very rigid structure, and communications are often implemented point to point, and every changes in the plumbing between different systems requires a very, very tough and hard work to do. What we are trying to do is, through this digital twin representation, we are capturing the status and relationships of every single system that can produce data. We are harmonizing their structure using the data models, and then thanks to the standard API, we are enabling applications, microservices that are aiming to serve the purpose of multiple stakeholders. If we see the diagram on the right part of the slide, we have examples, a transport robot publishing its particular ID, its current location in the factory, some internal parameters of the behavior. We have also a digital representation of a human role, which can be the operator warehouse. And we have different systems like, for instance, a palletizer robots, which is able to provide information on which is the lot that is now being processed in order to configure the pallet, which are the products that will be in there, which is the matching between the different IDs in the items that are being palletized, etc. What I mean in the end is the whole report of the operation that is happening. Thanks to this holistic representation of the context data, multiple stakeholders and even third-party systems or external organizations or remote facilities from the same organization can benefit from the access to this data to, in the end, make smarter decisions. Based on this overall idea, our focus now in the DIH² project is to accelerate factories through the use of robotics. This also connects with the concept that Mina was referring to as this capacity to absorb sudden changes in the demand and be able to reconfigure the production easily, being able to produce from very, very, very small batches to very, very mass production level with the minimum cost. And what is exactly the type of data that enables this type of interaction? Well, my classification used today, I am using today, is organized into 4 categories. First, I consider that one abstraction for the data twins is at the asset level. For me, an asset is every box represented here in the smart assets block. We have resources in the factory. We have parts of a particular product. We have the products themselves once they are assembled. We have the human roles as personnel. We have information systems, but we also have, for sure, and this is the key point in our use case, cyber physical production systems, systems that are able to alter the state of physical things in the factory floor. in particular, we are putting the focus on smart robots. And here, fusing data and being able to take the data out from the robots or to serve robots from, for instance, artificial intelligence application is essential for these four main topics in order to allow robots to automatically recover from failures and hence avoiding additional costs involving humans in non-added value tasks. Then this data can also help us in deploying robots in environments without the need of tailoring them a lot to a particular operation. And then we have concepts connected with the efficiency of the production, how a technician can easily and very fastly program the robot to do a new task, or how can it integrate the robot with different systems that are talking multiple languages. This is all the context that gravitates around every asset, but we are considering three more abstractions. The abstraction that focuses on the operation, which is the action of the robot that is required in order to have an intermediate or a final good ready, is a particular phase of the production. You have here some examples like picking and placing objects, transporting them, welding a particular part, cutting, polishing, every single operation, that if we put them in a sequence following a particular recipe becomes a process. We can consider that operations are focused on the workstation data, probably one single human role and one or two systems are enough to conduct such operation. But in a process, we are involving multiple workstations or multiple human roles or multiple point in time. So we need to create the necessary data that allows us to capture the status of this abstraction. And this is what we are doing at this level. And in the end, the full observability and traceability and this hyperconnectivity between all the system, what has as its final purpose is to allow the business to be optimized. And here I am putting some examples how executives can make smart decisions on the acquisitions, pricing, and they can understand in real time what is going on in the production floor, and then preparing, analyzing, and deciding better for the next time. So how are we materializing this in a technical platform? Well, in this first slide, what I have tried to capture is the separation of parts we are doing in the different environments. At the bottom, what we have is the cyber physical production environment. What this means is the factory floor, the one that accounts for the machines that are processing materials that are entering the world physically. Here you see that I am highlighting the concept of robotics and automation because this is the focus of the DIH² project. But other first-class citizens of this scenario are the conveyors for transportation of items, additional sensors and cameras, and systems for human-machine interaction and supervisory control of the physical operations. On top of this, there is a whole stack of technologies that is responsible for enabling real-time interactions, very, very often and typically wired communications between different physical systems. And then all of them are exporting some interfaces at different levels. There are probably, as is often in the case of autonomous mobile robots or cobots, are prepared to put the data directly into a network, or others, like for instance, large welding robots or palletizers, rely on a control cabinet that then has an industrial PC attached, and is this PC which is responsible of publishing this data as a server from the factory floor. The future consider a virtualization in which the virtual factory and the cyber physical production environment are totally linked through the data model. And here I have put the overall role of the virtualization. In general, we have 3D factory simulations, which might be even rendered in order to allow humans to see 3D visualizations of this simulation. We can simulate products, processes, and we can build intelligent systems. Here is where the whole stack of technologies for artificial intelligence, deep learning, machine learning, or even more basic rule-based systems allow the physical factory to be more efficient and more precise, and even maintain quality control while doing this increase in the efficiency. What DIH² is proposing? Well, it is proposing the creation of an IoT platform, ramp IoT platform, that is goes beyond than the role of just passing data from the physical environment to the virtual one, but adding context to it. And here what I have highlighted is kind of the three main problems we are dealing with. How to communicate the platform with the physical environment, how to communicate the platform with the virtualization, and what are the tools, what are the capabilities that this platform should contribute in order to generate added value. Regarding the first of the problems, we are aligned with the FIWARE proposal, and what we are doing is relying on the stack of IoT agents offered by the FIWARE technologies. I want to highlight that everything in FIWARE is open source, and it will be always open source, which does not mean that anyone can encapsulate this open source technology and create products around it. But everything that you can find in the FIWARE catalog is open source and will remain open. So what we are doing? We are creating specific agents that are able to translate every single industrial IoT protocol into context data. Being context data, this NGSI representation with IDs and attributes as a collection of descriptive properties and relationships. Then on top of this context data, which is served by a particular component of the FIWARE architecture that is named after a context broker, every single server of context data is typically named after context broker. We have in this server a snapshot of the current value of every single twin in the current moment, but then the FIWARE catalog is also offering a whole stack of technology to process, analyze, persist, and visualize the history of this data. So this is how we are dealing with the first problem. We first have our layer of agents which are able to talk to the different industrial IoT protocols. We have our harmonized representation in the context broker, which is serving the NGSI API, and we have a stack of technology to operate on the historical context data. But now we have the same problem, how to connect and communicate with the virtualization. Well, in general, there is a huge lack of standardization in this part, in the same way that we have difficulties to talk to every single device in the factory floor. OPC UA, for instance, or DDS or ROS are starting to standardize this part, but also in the connection with the virtualization, there are still a lot of alternatives, very, very heterogeneous approaches to perform this integration. In general, this is typically done using custom and often proprietary interfaces that allow efficient and certified point-to-point communications between the physical world and the virtual one. There are different platforms and services offering reliable exchange mechanisms for large files and large data sets, or different models that are necessary in the production floor. So what we realize is that we as open platform, our proposal must coexist with all these commercial solutions that are out there, with all the heterogeneity that is present nowadays in these solutions, and just offer an easy-to-use interface that allow a company to reuse everything that exists over there and take the most out of the new platform. And this leads us to the third problem we are dealing with, and is what kind of key enabling technologies, what kind of services should we be creating for the RAMP IoT platform. In particular, you can see highlighted the dashboard engine and the RAMP cloud. These are the two first services that have been built for the RAMP IoT platform. The dashboard engine is the one that allows to implement multiple dashboards for different human roles, for executives, for plant managers, for cell operators that are able to monitor the robotic cells in real time. And then the RAMP cloud is an environment in which some of the microservices can be offered as a service. I mean, when we are trying to materialize such a complex environment, it is often difficult for an SME to have someone that is ready and has the know-how to deal with all the different levels of abstraction. And because of this, it is necessary a cloud that is able to offer these microservices in a way that the know-how required is minimized. What are the next steps? Well, next steps are the development of programming tools that allow experts from the domain, and not necessarily experts from robotics or from physical automation, to generate different workflows in the factory floor. We have simulation tools that are aimed at allowing the virtual commissioning of robotic cells and the creation and generation of basic scripts that can be deployed in the factory floor and then tailored by experts, and hence reducing the time to get the robots ready to operation. And then the third pillar we are working now, because this is becoming cornerstone for the, not for the midterm or long term, but for the really shortcoming future, is the usage and integration of artificial intelligence, machine learning, and deep learning techniques with all the processes we are developing in the factory floor. So this is the whole vision we have in DIH². And we are materializing it in a number of use cases. Here I am attaching the 11 use cases we are participating on, and you here have the link to a more elaborated description on them. But just to highlight some of pills of how the data is being used. For instance, FITS is a project that is focused on logistics, and over there, everything gets connected in a factory, in a smart warehouse, in which a smart warehousing system was already there, an enterprise resource system was already there, and now the FITS experiment has brought a robot, a transportation robot, into the warehouse, and everything has its digital twin representation in a way that a stock transfer order arrives to the systems, and simultaneously the smart warehousing system, the enterprise resource planning system, the robot fleet, and a smart decision component gets notified, and everything becomes transparent. The smart component decision is capable of assigning the job request to the robot materializes the transportation, and automatically the status of the ERP and the warehousing system gets updated. We have, for instance, these use cases like A2CS or Agile Plus, and these guys have focused on enabling all the integration that is needed in order to estimate the OEE parameter. This parameter is a quite relevant parameter in production because it estimates the efficiency of the equipment that is working in the shop floor. And thanks to the digital twin, we are making the whole process traceable and observable, and we are able to estimate accurate overall equipment efficiency parameters. Then we have experiments like RoboWelder, Contra 2.0, JS2SF, which are working on multi-station scenarios in which the robot operation should notify operators or future working station in order to minimize the downtime in the floor. And in particular, RoboWelder is being the front runner in the integration of artificial intelligence with actual robot operations. In particular, they have built a microservice that allows to, given a batch of images, reconstruct a 3D model of the part and generates different paths that are suggested then to the welder to be selected as the welding path for the robot. Then for sure, the operation needs a very serialized, but this is the approach in RoboWelder. I can elaborate more on each of them, but please do not hesitate to contact me offline, and I can give you more examples or more details on this. The final message I have is that these 11 experiments are part of a first round of experiments in DIH². We are now starting with the second round. The open call is open, and you can apply there with a relevant experiment before the 30th of June. And again, if you consider that there is something here to you, please do not hesitate to contact us, and we will give you the necessary feedback. Well, that's all from my side, and now I'm open and available to answer your question.
Thank you, Francisco. Let me check if there's any question. But actually, I had one before checking for you. So all these experiments that you mentioned in that previous slide, they tapped into the platform that you've described. Were all these data flows and the use of this platform very new to them? Like, what I mean by that is that was it something they really had to make big efforts to adapt to, or did they actually have to hire, for instance, new people?
Yeah, for manufacturing SMEs, this is in fact a huge effort. Why? Because they often are lacking experts that can cover the solution end to end. They have experts in the domain. They have experts in the welding operation. They have even experts in one particular robot, but they struggle to create this whole integration with the digital platform on how to give visibility to all the data they have, or how to process it, store it, and reveal the value that the data is capturing. So what we are trying is to bring this type of power to them at a cost that they can afford.
Okay, yeah, I was wondering. Thanks. Okay, regarding the questions, I'm having a look on Google, and we don't seem to have any. So in that case, we can simply move on to the next and final part of the presentation, and that would be you, Marcos. And thank you, Francisco.
Thank you. Bye.
Hi everyone, I'm Marcos Matas, and I'm happy to present today. Then just share my screen first, and then we're good to go. So I hope that you can see presentation mode in just a minute. That's great. So first of all, I'm really happy to present after the previous two speakers. It was really interesting. So I will try to give a bit the perspective of the network that was, I think, somehow mentioned from Mina. So the fact on how SMEs, after succeeding in digitizing their processes through digital twins. They can be connected to global supply networks. So this will be, I think, the focus of my presentation on trustworthy data ecosystems. And yeah, in fact, I want to start with an overall message that the association that I'm working for represents the International Data Space Association, that when it comes to data sharing, it's all about creating vital ecosystems, which by that we
Marcos, sorry, just a comment. We still cannot see your slides. So I don't know if you're actually presenting. Maybe you're not.
Of course, I mean, at least I was trying to present. So,
no problem.
Thank you for letting me know. So what do you see now? Oh, okay.
Yep, now it's starting to load. Yep, we can see it.
Okay. Presentation, right?
Yeah, we can see the fish and the ocean.
The fish in the ocean is what you're supposed to see. Okay.
Right.
And that's exactly is a viral ecosystem. And by that, obviously, what we mean here is that, yeah, in order to data sharing contributes to this exactly thing. So to create data ecosystems where new value can be created when data are being efficiently shared, because in order to extract the full data of what SMEs and other companies will generate through the digital twins, you need to share it, or you need to consume data, because in today's manufacturing and global environment, there's no isolated company. So in fact, there's a lack in sharing. There's a lack of data sharing, especially when it comes to SMEs, due to the risk that it comes with it when you share data. And this is exactly what we are trying to address as an issue, as an association with a reference architecture model that I will talk about in a bit, because one of the key things that is blocking this extended data sharing into ecosystems is the trust and the risk of letting data go out in fear that you will lose competition because others will have access to your data and so on. So trustworthy ecosystems, data ecosystems, the key message here. And I'm going to talk about two aspects. So the digital twin for sharing data across the organization as a continuation of what Francisco presented before, and the role of industrial marketplaces such as the one that has been created for DIH², which I forgot to mention in the beginning. I'm also together with my organization, we're representing IDSA in this project, and we are contributing to standardization activities of the ROS APIs that are created. So focusing on this third part of this nice view of the digital twin approaches, the first one being building blocks to solve, to create smart solutions in a vertical way, and the second one's to create this smart organization where the digital twin is supposed to integrate different systems within the smart organization. The third part is the data spaces, is how data can be shared across organization actually, and create a bigger digital twin representation of the world. So in a manufacturing let's say scenario, this would be the digital twin of the whole supply chain. And in fact, if this would be possible, SMEs that usually produce something for an OEM could really benefit from being part of this chain, let's say, of connected digital twins, and at the same time the need to be sure that nobody has access to the data, or if they have access to the data, of course this is necessary, they don't lose the control of it. And this can be ensured with what we call the concept of data sovereignty. And this data sovereignty concept is actually the company being able to control the data and manage how exactly it is being used from other participants when they want to exchange data. So the way we do that is that we have developed a reference architecture model that can be used for data spaces that allows different participants to set some rules on how the data that they are sharing is being used. And only if these rules are followed from the data consumer, the data provider can give consent for the data to be shared. So I don't want to go into very deep details. I just want to give you like the design principles based on which we want to allow this data ecosystems to be created. So there are three key principles that a data space, which is nothing more than a decentralized data ecosystems, builds around commonly agreed rules and commonly agreed building blocks, let's say, that enable the participants of an ecosystem to have trust with each other. The one thing is data interoperability, and this is something that we need to make sure that all participants understand each other and there's sufficient exchange of data. And this requires, of course, a common language for every participants to know what exactly data they're receiving, to know exactly how they can need them. And for that, we need definition of common data models. This is, for example, something that FIWARE definitely supports in. And to mention here, FIWARE is, of course, one of the supporters and actually one of the data space contributors with their own connectors and components for that. So interoperability is the first part, and we cover it with an information model that we have created that allows unlimited interoperability and for people to use common agreed APIs for the exchange of data. And the second part, which is really the most important part here, is the trust and data sovereignty. So the technical means the technical means that will guarantee that participants in the data space can trust each other. So we formed a way of people going through a certification process that shows to the rest of the data space participants that my components and my organizational environment is trustworthy. And at the same time, we have the connector, which is the most important component that you need to know, which is basically the data gateway that allows two parties to exchange data. So this is what enables the trust. And finally, we have the governance, which basically is a set of not only user rules for the data flows, but also a set of operational, organizational, and business agreements that the parties need to agree on. All this should, of course, pay to the overall goal of data value creation. This is basically what data spaces should provide. So components that will allow people, participants to exchange data, and for the data provider to probably get also an incentive for it. So creating data value, but of course, this means that there will be new maybe services that will allow companies to monetize from data and not only exchange in a sovereign way for other purposes. So yeah, and I'm finishing with technical stuff, but this is quite important for you to know, and it will follow also in the rest of the presentation a bit. So what I would just describe in these three key pillars of ideas, international data spaces, is what components you see inside the circle that makes sure the data space operates in the way it's supposed to be. But the most important thing that you should pay attention to is what it is on the circle. So it's the connectors. It's the key component that allows two companies to exchange data. And I would say once again, the data can be exchanged only if the provider of the data, let's say here that the company on the top wants to consume some data from another company that will help the company improve the production process. So through the connector, through the broker actually, it can search for the data, and when it finds the data, this company on the top requests for access to the data. And the data providers or the company that will share this data can agree and say, okay, you can use my data, but you can use it only once a day, or you can only use some masked data, so data that are anonymized, or you can use them 5 times and then you have to delete them, or they are deleted automatically. So we have both technical and legal enforcement here, and this allows everything to be in a trusted environment that we call. So if we transfer this to digital twins, and I'm just using now, let's say, 2 examples that I think that totally represent a bit how we can see the future when data spaces become a bit more come to the market in a way that SMEs and OEMs and everybody can join different kinds of data spaces in different domains. We have like 2 things. The first one is what was mentioned before from Mina as well, the challenge that is there for SMEs to participate in bigger supply chain networks because of different ways of understanding data, but assuming that this can be solved through the interoperability functionalities of data spaces, assuming again that an OEM is really interested, and since with greater visibility, agility, flexibility, they need to prepare for in a short term about changes that might happen in the production systems. If, let's say, an SME that produces something for an AM can give access and visibility through the digital twin to what is happening in its production system, it can probably gain a competitive advantage by letting the customer, let's say, which in this case is the OEM, know how exactly a production is happening right now, is progressing, and what should be the end result that should be expected. So if there are any delays in the production and so on. So offering this kind of visibility, and let's not forget here the fact that a digital twin is not limited only to data that are created right now. So it doesn't only do a real-time or soft real-time or whatever we can call it digital twin representation, but it can do also something more than that, something like a forecast based on tools that they can use for simulation and so on. So this means that powered with what FIWARE is providing as an architecture, an OEM can expect from another company that they can not only give them an idea of how production is running right now, but they can also give them a prediction about how it will be in the next hours. So this only makes the position of SMEs in a global supply network more advantageous in terms of being selected to participate in such supply chain networks instead of other companies that are not like in the trusted circle and don't agree to share the data that easily, or don't have the way to communicate the data in a way that an OEM can easily understand them. So this is definitely one benefit of a data space. And the other has to do overall with monetization of data. Imagine that the data always, not always, but in many cases can cover a certain value. So when creating the digital twin and gathering data, this kind of data can be very interesting for others that want to do something similar, or they just want to use them in order to validate that their digital twins could work in a way that they envision it, or models could be trained based on others' data. So there are many scenarios that we can see that an SME can at least has the ability to upload its data that it generates in a marketplace, which is nothing more, as you will see in this case, as marketplace can be another pink or magenta box in this data space, and can upload this kind of data to this data space. And other companies might be interested in them. We know from cases, from projects that we've done in the past that, for example, there's an EU project that we participated that did this exactly concept for companies uploading data, and they could be reused, traded in data assets. So innovative services could be created. So an SME could provide its data, and others can assess whether they want to use it and what price they would pay for it. And this can create a new value for the company providing this kind of data. I want to talk finally about how we see the evolution of marketplaces, since we're talking here about DIH² and its marketplace, which is the ramp. And in fact, since this is based also on the FIWARE principles, it's something that we can see also happening in the future. So I will try to explain a bit the traditional scenario of trusted industrial data spaces and the future scenario. So right now, industrial marketplace can, from our perspective, be just simple participants, as I showed before, as I mentioned before, of the IDS ecosystem. So they can participate in one and have their own connector, and in a way be certified that they are trustworthy. And on what you see on the left, what they can do, they can proliferate trust based on their certification in the IDS ecosystem when it comes to data and applications to the customers of the marketplace. So what we'll face in the future when IDSA will be brought to the market massively, we will have a paradigm shift in how business is made, actually. So traditional marketplaces act regardless of the domain. So it can be high tech or big data domain or agile production. I just mentioned just some kind of marketplace that are out there. And they right now are a trusted third party that can handle data and apps, so companies can upload data, consume data, because the marketplace itself serve as some sort of trusted party. From our perspective in the future, the more people are part of the IDS ecosystem, as you see on the right, and they are connected with the IDS connectors, the more easier it can be for the marketplace to abandon the traditional stakeholder network and just have the opportunity to say, okay, now a lot of companies that want to be part of the marketplace and trade there have IDS connectors, are trusted. They can abandon let's say all the components that they need to build in order to ensure that they have trust, because the ecosystems itself, the IDS ecosystems can offer this, and I will show you in a bit how. And this will give the opportunity for marketplaces to focus more on how they want to make business by matchmaking, connecting data providers with data owners, and also service consumers with app providers with app consumers, and so on. So in fact, back to this, and just want to show this, in the future, you can consider that marketplace can be inside this circle, so can play the role of metadata broker that is already playing in many cases, or be the role of app stores for the one that want to use some applications and others offer it in a marketplace. We've seen this happening in many use cases. I'm just referring here to two that show this trust part of industrial marketplace based on IDS standards. And there are, of course, more to come. And again, here, RAMP as a platform has this capability systems closely linked to FIWARE developments. Yeah, so I just want to close like my speech with this view of what would be the vision regarding the participation of SMEs and in manufacturing data ecosystems to truly unlock the value of data and the digital twins that are created, but always the gaps that are identified, especially when it comes to SMEs, where they don't like they're not used to extend that much data. But first, we need to make sure that we digitize the SMEs production environment based on robotic applications or any other way that we can make sure that it will help them, be part of agile production ecosystems, and secondly, perform a kind of mindset of how data is handled. So thank you very much, and I'm happy to answer any questions, and I hope that I didn't make it complicated for you.
Thank you, Marcos. Let me check. We have a few questions. No, we don't seem to have any. But in any case, well, if some of you have some questions during the conclusion, you can of course ask them. Just maybe to conclude, I'll share my screen and show you some of the opportunities that are related to our project right now. Just a second. All right. Marcos, Francisco, you can see my screen, right?
Yes.
Okay. Okay. So again, two main initiatives involved in this session. The first one being Trinity, that Mina is coordinating, and actually Trinity has an open call open right now, though I understand it's actually ending soon at the end of this month. Mina, do you want to speak very briefly about this opportunity?
Well, we still have the call open, so well, the Tuesday is the last day for applying, but let's see how it goes.
Okay.
It's coming very shortly.
Yeah. Okay. Well, in the framework of DIH², as Francisco mentioned, we also have an open call open, and for this one you have a bit more time because it will be the deadline is on the 30th of June. So we are inviting, on the one hand, innovative robotics technology provider from all over the European territory to apply with a manufacturing SME. And the winners can receive up to 248,000 euros of funding, as well as premium technology integration service. So if you're interested in the call, you can get in touch with me. And if you know people who could be interested, you are more than welcome to spread the word. And then we have coming up a few other opportunities that are related to fostering the use of robotics for SMEs. One is AI Regio. So the aim of this project is to enable manufacturing SMEs to easily implement AI solutions into their production processes so that they can optimize these processes, improve quality control, and improve also human-robot interaction. And the open call for this one is starting on the 1st of June. And Mina is involved in this project, so you can get in touch with her. Now, another robotics-related project is a kit for SME. Sorry. So the aim of this project is to enable, oh, my bad. Actually, I'm sorry, I got confused. The description I just gave you was for Kit for SME. So Kit for SME, you know what it's about. And for AI Regio, it's the following. It's directed to SME-driven experience on AI for manufacturing solutions. So 2 different open calls, but both related to robotics. And both of these open calls are open from the 1st of June. So this is it on our side. So thanks a lot for attending. Thanks to the speakers, Mina, Francisco, and Marcos. It was great to have you all. And well, see you soon, and get in touch if you need any information regarding these initiatives in which we are part of.